Okay, good morning, guys. Today I am going to be recording for you systems of equations in context, and these are examples of the word problems that you are going to be encountering while working exercises so that you have an example of each. So I hope this helps you. Here is one. At the gift shop, they sell small greeting cards and large greeting cards. The cost of a small greeting card is $2 and the cost of a large greeting card is $5.45. How much would it cost to get 3 small greeting cards and 2 large greeting cards? And then the second question is how much would it cost to get X small greeting cards and Y large greeting cards? So basically, it's giving you the cost of a small greeting card, so we could make a little equation here and solve it. So we could say the cost of a small greeting card, so let's say 2 per small greeting card plus $5.45 are the large greeting cards. So $5.45 are the large greeting cards. Let's use L for large. Okay, so $2 is small and $5.45 is large. How much would it cost to get 3 small greeting cards and 2 large greeting cards? Well, if that happens, let's say that S is the number of small greeting cards, so 2 times 3 plus $5.45, and that's 2 of them. Whatever that is, that would be my answer. So 2 times 3 is 6 plus 545 times 2, that is what, 1090? So $10.90 and $6, that's a total of $16.90. So that would be, the cost would be $16.90. And that's what you would enter here. Now, what is the total cost of X small greeting cards and Y large greeting cards? That means you do not know the 3 and you do not know the 2. So the X is for small, so instead of 2S will be 2X. Plus 545 Y, and that's what the cost would be. 2 times the number of small, $2 times the number of small greeting cards, plus $5.45 for the number of Y greeting cards, depending on however many you get, and that would be the answer in terms of X and Y. Okay, let's look at another one. At the Natural History Museum, tickets cost $18 for adults and $5 for kids under 12. How many total tickets would someone get if they purchased 11 adult tickets and 18 kids tickets? Notice they gave you price, but the question has nothing to do with price. It has to do with the quantity. How many total tickets would someone get if they purchased 11 adults and 18 kids? Well, that would be 11 plus 18, right? Where would it be the adults plus the kids, which in this case the adult tickets is 11 and the kids tickets is 18. So total is 11 plus 18. So this one would be A plus K for the bottom, and the one total tickets 11 plus 18, that would be 29 tickets. Okay, this is another kind of problem that you're going to find. It says Mason went to the grocery store and bought bottles of soda and bottles of juice. Each bottle of soda has 45 grams of sugar and each bottle of juice has 15 grams of sugar. Mason purchased a total of 11 bottles of juice and soda, which collectively contain 285 grams of sugar. Write a system of equations that could be used to determine the number of bottles of soda purchased and the number of bottles of juice purchased. Define the variables that you use to write the system. So you can use your own variables. So that's great. Okay, so let's take a look at this. They are asking me to create a system of equation, and they're letting me define my variables. So It says each bottle of soda, so let's use S to make it easy. Let's use S, and that would be the number of bottles of soda. And let the use, for juice, let's use J. J for number of bottles of juice. Okay, once we have that, then we need to see what is it that they're giving me. Say, bottle of soda has 45 grams of sugar. So I'm going to highlight this because these are talking about grams of sugar, and each bottle of juice has 15 grams of sugar. That's also talking about grams of sugar. Mason purchased a total of 11 bottles of juice and soda, which collectively contain, so together contain 285 grams of sugar. So here you have the grams of sugar. So I could make an equation. I would say 45 grams of sugar for soda. So 45 plus 15 grams of sugar, and that's per juice. And the total for that collectively contain 285. So collectively contain 285. Now notice these are grams of sugar. Grams of sugar per soda, 15 grams of sugar per juice, and together collectively 285 grams of sugar. So the other equation has to do with something else. So Mason purchased a total of 11 bottles. Notice the bottles do not specify which. So that means for the bottles, that's what's going to be the difference, right? That's my other equation. So my other equation, that means between sodas and juice, it should be a total of 11. And there are my two equations. So basically, I defined my variables and created my two equations, okay? So that's how you do that. Okay, here is another example of that type of problem. It says a summer camp is organizing a hike and needs to buy granola bars for the campers. The granola bars come in small boxes and large boxes. Each small box has 12 granola bars and each large box has 18 granola bars. The camp bought a total of 15 boxes that have 240 granola bars altogether. Write a system of equations that could be used to determine the number of small boxes purchased and the number of large boxes purchased. Define the variables that you use to write the system. So here is the two variables that I'm going to use. I'm going to use S for small and L for large. Now, S stands for number of small boxes. And the large is number of large boxes. Okay, so now that we have that, now we create the equation. So now let's look. The camp bought a total of 15 boxes. Okay, hold on. Each small box has 12 granola bars. So this deals with the quantity of granola bars. And each large box has 18 granola bars. The camp bought a total of 15 boxes that had 240 bars altogether. It's granola bars altogether. So this deals with bars, bars, bars. However, this right here doesn't deal with bars. It deals with total boxes. So these deal with boxes. Okay. So we could create the equations by using the boxes. The boxes would be the small boxes plus the large boxes equals 15 boxes. See that? And then the small boxes has 12 granola bars. So 12 per small plus 18, the large, should equal a total of 240 granola bars. And there is your other equations, okay? So there are my two equations and my variables, all right? Okay, here's another type of problem that you are going to be encountering. It says Jordan is working 2 summer jobs, making $13 per hour lifeguarding and $10 per hour walking dogs. Last week, Jordan earned a total of $177 and worked 3 more hours lifeguarding than hours walking dogs. Determine the number of hours Jordan worked lifeguarding last week and the number of hours he worked walking dogs last week. Okay, so basically you have to do what we did before. We have to create the system of equations, right? So let's define the variables. Let's see. He works lifeguarding, so let's choose L for lifeguarding. Whatever hours he worked lifeguarding, and let's choose W for walking dogs. Okay, so let's see. He makes $13 per hour lifeguarding, so I would say it's 13L plus, notice this is dollars, right? Making $13 per hour lifeguarding and $10 per hour walking dogs. He made a total of $177. So you notice dollars for total. So $10 walking dogs, so 10W, and that equals $177. So the next part, it says he worked 3 more hours lifeguarding than hours walking the dog. So let's assume, let's make a little table here. He says he worked 3 more hours lifeguarding than hours walking dogs. So let's say W for walking dogs, L for lifeguarding. So if he worked, think about it, if he works 1 hour walking the dogs and he works 3 more hours lifeguarding, so that means whatever that, he worked 4 hours lifeguarding. So 1 plus 3 is 4. If he works 2 hours walking the dogs, then he worked 5, because 2 plus 3 is 5. So he would, let's say he worked W. So that would be W plus 3, right? So that means L is the same as W plus 3. So here is my equation. L equals W plus 3. Whatever he walked, plus 3. Okay? Because he worked more hours lifeguarding than walking dogs. So therefore, now we have the two equations. We could say this is X. We could call L X. And we could say W is Y. Now you could go and put that on a graph using X and Y. So you would have to write the equation this way. 13X plus 10Y equals 177. The other one would say L is X, so X is equal to Y plus 3. And those are the two equations you would put on decimals, okay, on the graphing calculator, and look for that point of intersection, and that would give you the solution. However, I'm going to do it just for practice here. I'm going to do it by substitution, because I already know the value of X is Y plus 3. So I'm going to enter that 13 times Y plus 3. Notice I substitute the X over here for Y plus 3. Plus 10Y equals 177. So that means that if I distribute here, that would be 13Y plus 13 times 3, that's about 39, plus 10Y equals 177. 13Y plus 10Y, that's 23Y plus 39 equals 177. So that means I would have to subtract 39 from both sides. So 23Y equals 17 minus 9, that's 8, 6 minus 3, that's 3, so that's 138. 177 minus 39 is 138. Then divide 138 divided by 23. So that means y is 138 divided by 23. That means y is 6. Since y is w, Jordan worked walking dogs were 6 hours right there. So I already have W. You see, I already have the walking the dog. Now, lifeguarding, I just need to plug that back here. So 6 plus 3. 6 plus 3 is 9. So that means 9 hours lifeguarding the dog. And I did it like that. You could just put it on the calculator, on a graphing calculator, and it will give you the solution for X and Y. X would have been 9 and y 6. So that's your solution on the calculator. Okay, here's another type of problem that you're going to have there. It says at a particular restaurant, each pizza roll has 70 calories and each slider has 350 calories. A combination meal with pizza rolls and sliders is shown to have 1,400 total calories and 8 more pizza rolls and sliders. Graphically solve the systems of equations in order to determine the number of pizza rolls in the combination meal. Let X and the number of sliders in the combination meal Y. Okay, so to determine the number of pizza rolls in the combination meals is X. So X for pizza rolls and Y for sliders. Okay, so I'm going to start with my own variables and then I'm going to switch them. All right, so here we are. We're talking about calories, so let's look at this. 70 calories, 350 calories, and 1,400 total calories. So sliders has 350, pizza rolls has 70 calories. So let's say that 70 calories per pizza roll plus we have the 350 calories per slider, and that's a total calories for both of them of 1,400. So there is one of the equations. The other one says that we have 8 more pizza rolls than sliders. So that means if we have a table with sliders and pizza rolls, let's look at this. If we have 1 sliders, it says we have 8 more pizza rolls, right? So that would be 9 pizza rolls. So if we have 2, that would be 10. That would be, if we have any type of slider, whatever the sliders are, plus the pizza rolls, or plus 8, right, would be the pizza rolls. So 1 plus 8 is 9, 2 plus 8 is 10, S plus 8 is whatever the pizza rolls. Okay, so pizza rolls will be S plus 8. So here are my 2 equations. Now let's change that so that we are able to solve it for X and Y. It says that, let's say pizza rolls are X, so pizza rolls is X. So that means pizza, the P is going to be X. So let's write that, 70X plus 350Y equals 1,400. And then we have P is X equals Y plus 8. Okay, so let's take a look at that. Now, if I put this in standard form, it would say X minus Y equals 8. See, so now it's in standard form. So now I know that the y-intercept would be -8, which I don't have, it's down here, but the x-intercept is 8. So I have a point right here. The slope is the opposite of 1 divided by -1. So -1 divided by -1 is 1. So I could put a point from corner to corner. So that's basically my line. So the first line goes from here up. corner to corner because the slope is 1. So there is my first line. That's this line right here. Okay, for this one, I need to find my y-intercept is 1400 divided by 350, and the x-intercept would be 1400 divided by 70. Well, I know 1400 divided by 70 is 20. That's my x-intercept. So I have a point right here. Oops, let me go back. Let's put that point right there. So that, once I have the x-intercept, then I need to look for the y-intercept. So y-intercept is 1400 divided by 350. Let's see what that is. 1400 divided by 350. Is 4. So that means the y-intercept is 4. So that means the other line goes from here to there. Okay. So that means my solution is right here at 10, 2. See, whatever that, or whatever that point is of intersection. Okay, that would be my solution. Let's make that thinner. Sorry about that. There we go. So my solution is right there, the intersection of the two. So that would be the graph. Okay. So hope this helps you. Just practice. And if you have any questions, just come by my desk and I'll help you out, or just raise your hand, I'll help you out.